Hello there. Now let's discuss about the ADAS specific electronic control unit, which I am going to address as domain control unit, ADAS domain control unit. Now let's deep dive into this ADAS domain control unit, the various subsystems etc. comprising the ADAS domain control unit. Now modern ADAS domain controls designs requires high power efficient solutions for video and object data processing. Now this is very important because data coming from camera or lidar or sensor must be very efficiently processed. And also safety diagnostics included or added to the system to ensure operation in all conditions. In one of the other videos, there is something called sensor redundancy. I clearly explain what is meant by sensor redundancy. If at all there is any particular sensor which fails, other sensor should stand up and do the job. Next is high and low speed communication interfaces to be used with sensor modules with or without processing. The overview of domain ADAS domain control unit. The ADAS domain control unit consolidates ADAS functions into single high performance electronic control unit. Now let me reiterate, don't get confused between electronic control unit and domain control unit. Both are essentially the same. It is just a different nomenclature or different jargon. It reduces the complexity, improves the efficiency and enables advanced features like autonomous driving. And it typically interfaces with sensors, actuators, networks like CAN, LIN, Ethernet, FlexRay, and it also interfaces with centralized compute platforms. It may be AI accelerators or GPUs and FPGAs. Alright, now these centralized compute platforms, they may come from NXP or Infineon or STM. So there are many kind of compute platforms that are available ready-made in the market. It may even come from Texas Instruments. So these microprocessor control unit manufacturer people, they ensure that it has proper compatibility with the ADAS DCU. Now let's see the various subsystems in the ADAS domain control unit. Now the ADAS domain control unit consists of several key subsystems that work together to process data and execute ADAS functions. Now sensor fusion and perception subsystem. The very purpose is it combines data from multiple sensors to create unified environmental model. Now everybody by this time must be familiar with what is meant by sensor fusion. Now what are the various components? It has a camera processing unit. It processes the visual data for lane detection, traffic sign recognition and object classification. Okay, I am sure everybody knows that by now. They understand that object classification is strictly the prerogative of camera. Radar cannot do that, lidar cannot do that, and of course ultrasonic sensor cannot do that. Object classification is strictly the job of the camera. Next comes the radar processing unit. It handles object detection, speed estimation and collision avoidance. And lidar processing unit provides high resolution 3D mapping for precise object localization. The ultrasonic processing unit used for parking assistance and low speed object obstacle detection. And next is the sensor fusion algorithms. Now in the sensors module, I mentioned about various types of sensor fusion algorithms that are available in the market, and the most popular is of course the Kalman filter. Now in the domain control unit, there is one more important subsystem called decision and path planning subsystem. The purpose is it determines the optimum driving strategy based on the sensor inputs. Based on the sensor inputs, the most optimal driving strategy is decided. And what are the components? First is object tracking and prediction. It estimates the future positions of the vehicles, pedestrians and obstacles. This is like simple extrapolation of the position of the vehicle. And next comes the behavioral planning. It decides the action, lane change, braking, acceleration. And next comes the path planning. Computes safe trajectories using algorithms like ARRT or medical predictive, model predictive control. So these are all the various types of path planning subsystems. Next comes the control and actuation subsystem. Now this control and actuation subsystem is very important, and this has to be very efficient because this is the actual executioner. Okay, always remember that this actuation subsystem is the actual executioner. Now it executes driving commands by interfacing with vehicle actuators. And now what are the various types of actuators used in ADAS? Well, by now you would have guessed: steering control, brake control and throttle control. In other words, steering, brake and accelerator. Alright, let's proceed further. Next comes the vehicle communication and network subsystem. Well, by this time you would have understood that communication is nothing but a kind of a neural network in human body. Whatever job the neurons and nerve cells does in the human body, the same job is executed by the communication protocol. Well, again, what are all the various types of communication protocols? The CAN FlexRay interface, the Ethernet backbone and vehicle to everything. These are all the various types of network and subsystems. Next is the safety and redundancy system. The purpose is ensuring the fail-safe operation in case system of failure. Now this is slightly, how to say, the sister system of the or brother system of the diagnostics. That's the reason it has components like diagnostics and health monitoring. It checks the sensor and processing unit integrity. It has fallback mechanisms, switches to backup systems if primary systems fail, and it has its own ASIL compliance calculation. Okay, ASIL compliance calculation is a very important part of the functional safety standards. Is it clear? Next comes the AI and compute acceleration subsystem. Yeah, excuse me. The purpose of this AI and compute acceleration subsystem is it provides high performance computing for deep learning and real time processing. Now this is very important. High performance computing, because of the magnitude of data that this domain controller unit is ingesting every minute, every second. High performance computing is of paramount importance. And what does this further comprise of? It comprises of the AI accelerators like GPU, graphic processor units, or FPGA or TPU. It runs neural networks for object detection and scene understanding. And multi-core processors like ARM, x86, RISC-V handles parallel processing of multiple ADAS functions. What about the memory and storage? Memory and storage is also important subsystem. They have high bandwidth memory for fast data access. Now this is a common knowledge that whether it is a computer or a laptop or a mobile, the more higher bandwidth memory it is equipped with, the faster it can access the data. Last but not the least, power management system. Components like camera, components like radar, it has its own power management system. Likewise, domain control unit also has its own power management system. It ensures stable power supply and low power operation depending upon the exact terrain or exact scenario on which the vehicle is operating. Is it operating in a very high crowded environment where maximum amount of data is being ingested, or maximum amount of data is inflow? During that time, power consumption may be more, otherwise power consumption may be less. So during this fluctuating power consumptions, voltage regulators and low power modes, they ensure to provide stable power to compute this compute and sensory modules, and in the low power mode it reduces the energy consumption when ADAS functions are inactive or ADAS functions are meager. Okay, so now you understand that various kinds of working scenarios, various power requirements are prevalent. Now, what are the key ADAS functions managed by DCU? I am just telling this for sake of a brief recap. Adaptive cruise control, automatic emergency braking, lane keeping assist, traffic sign recognition, blind spot detection, parking assistance, cross traffic alert, highway pilot, which is a level 2 or level 3 autonomy. These are all the various types of functions that are managed by the domain control unit. And let me reiterate, domain control unit is nothing but an electronic control unit. It's just a different jargon. Alright, next comes the future trends in the ADAS domain control units. Centralized zone architecture combining ADAS with infotainment and body control into single compute platform. AI driven perception, the more advanced deep learning models for better object recognition. These are all the various types of trends that are slowly making foray into the ADAS domains. Next, of course, the 5G and V2X integration, faster communication for cooperative driving. Now, by this well, in the entire tutorial, this V2X integration has been explained several times. It's nothing but communicating with the other vehicle or the infrastructure or the pedestrian or a mobile in the vicinity. When it comes to OTA updates, continuous improvement of ADAS algorithms. When it comes to OTA updates, it is nothing but continuous improvement of ADAS algorithms. Instead of going to the service station directly from the satellite, the software can be upgraded. This is what is called OTA update. What does OTA stand for? Over the air. OTA means over the air. OTA is nothing but acronym for over the air. Thank you. Hope all of you got a reasonable idea about the various types of the various types and various subsystems prevalent in the domain control unit.